Hi, this is Dan, and this is the solutions video for Math for Liberal Arts, chapters 2, 3, and 4, test spring of 2013. The first question here is pretty straightforward: multiplication of fractions. You could identify that you could cancel the 6 and the 4 and reduce those to 3 halves. You get 3/10, or just multiply straight across and then reduce to get 3/10. On 2, convert 15 miles into yards, and it tells you there's 1,760 yards. So it's nice to see this work here. And if you didn't have the work, I couldn't give you, and you got it wrong, you'd lose both points. But if you showed some work, I could get some correct thinking. So just take 15 miles times 1,760 yards per mile. The miles cancel. You get 26,400 yards. And for B, or for this one, car is driving 180 miles an hour. How many is that miles per minute? So this is miles per hour. If you want to cancel hours, you put the opposite, hours in the denominator, hours on top. We want to convert it to miles per minute. There's 1 hour, 60 minutes. So really it's 3 miles per minute. And you can just kind of think about that. If you go 60 miles an hour, that's a mile a minute. If you're going to triple that, that's 3 miles a minute. And I've never gone that fast. Number 2, find a common denominator here, just basic addition or subtraction of fractions. So that's 1/5, same thing as 2/10. 2/10 minus 1/10 is 1/10. Number 5, convert to decimal. I mean, you could take 9 divided by 2 or just realize that's 4.5. On 6, you're supposed to determine if it floats. Its density is mass divided by volume. I gave you the formula. So the mass is 2 kilograms. Volume is 3 liters. It's 0.6 repeating kilograms per liter. If it's less than 1, it floats. If it's over 1, it sinks. And number 7, a lot of people had a problem with this one. If you took 140 times 70, that gives you the area in square yards. The question is, how many square feet are in a square yard? So if you think about it, there's 3 feet by 3 feet is a square yard, so 3 by 3 is 9. So really you got to take this 9,800 times 9. Another way is you could take 140 times 3, get the feet, 70 times 3, get the feet, and multiply all that out, you get the same thing. 88,200 feet square, or cubic, or I'm sorry, this should be square feet. I'm sorry, this should be square feet. On number 8 here, it says, if you get a 10% increase and then you get a 10% pay cut, is this the same? The easiest way is just to try it. Let's say you make $100, get a 10% increase, $110. Now you lost 10%. What's 90% of that? Is 99, so you're actually making less, so it is lower. And this next one is a consumer price. You have to set up a proportion, so you have to look at, and they're comparing 1991, so we find 1991 here, and so we say, all right, the index is 136.2, so 515 is to 136.2 as, I don't know, X is to 2008, which is 215.3. So you cross multiply and divide, and so $5.15 an hour in 91 is essentially the same thing as $8.14 in 2008. Number 10, this was a really poorly worded question. I apologize for that. You get on the scale, it says 95, but you're really 100. So the question is, do I compare that difference, which is 6 pounds, compared to what it should have been, or compared to what it read? And so I accepted both. So you could say it's 6 pounds off compared to the 95. It's 6 pounds out compared to 101, and it's 6 pounds off compared to the 101. I think the answer, it's no matter how you interpret it. Essentially, the only way you miss this is if you put A or nothing. So hopefully the next time, really it's just change divided by original. So if we reference it, if the original is 101, then it's reading 6 pounds light, and that would be, so it's probably B, but yeah, it's just poorly. You're just not sure which do you care, which comes first, your weight or the scale's weight. On 11, if you get a 10% increase 10 years in a row, well, I get twice as much. Well, you can think about it. Well, 10%, that's 100%. So yeah, it should be a 100% increase. But that's not true, because you actually get compounded interest. So you can just try that. If I make $100, 10% increase, 110. 10% increase the next year, I'm going to get $11 boat. So now I'm making 121. So I'm making compounded. So it's actually going to be much higher. 12. Just take that 6,550,000,000 divided by the population, and you get like $2,450, which in scientific notation is A here. On number 13, they said, compute the compound interest, essentially the balance. If you let some money, $4,500 sitting there for 3%, 6 years, compounded monthly, and you just run it right through the formula here and get B. A lot of people miss this next one. If you use simple interest, remember the simple interest formula, which is right in your formula sheet, is I equals PRT, principal times rate times time. So there's principal, there's rate, there's time, $810 in interest. Add that to the original, you'd end up with $53.10, and obviously you get more if you compound more often. And then what if you did it just once a year? So it's the same thing as a compound interest formula, except we're just going to do it 6 times. So it's just n or the number of times is 1, so it's 1.03 to the 6th, and you get 53.73, a little bit less. On 14, this is the annuity. Put $82 away every month, and I copied this right off your formula sheet and just plugged in the numbers here, and you should get $72,727.17. And you're supposed to compare that. It says compare that amount to the total amount deposited. Well, how much was deposited? $82 times 12 times 39 years. So there's $38,000 deposited, but you end up with $72,000. So what's the difference? You made $34,000 just because of the interest, not having to work at all for that money. On 15, let me make sure I get that. Yeah, on 15. Calculate the payment here on a house. So here's the payment loan formula. Plug all those numbers in. You get $501 for the 30 year, $776 for the 15 year. And then how much are you going to pay for the whole loan? Well, there's my payment. And for 30 years, there's 360 payments. So that house eventually is going to cost me $180,000. You're supposed to compare that to what it actually costs for the house. So you're essentially $75,000 in interest. 15-year mortgage is only 180 months. You'll end up only paying $139,000 for that house, and only have $34,000 in interest. So it says which is better, and obviously it's the 15-year. You're going to save over $40,000 in interest by cutting it off, cutting the term in half. So on 16, early in the loan, does it mostly go to interest or principal? And yeah, it's true. This mostly goes to interest, and the low amount goes to a principal. 17, I copy pasted compound interest, or the sorry about that. This is the how much do I need to put in today, which is the principal, to get a future amount A. So this is essentially the compound interest formula, but it's reversed. We just solved for P instead of A. So there's $3 million I want in the future. Plug in all the variables, 0.07, 12, 43 years. So if you have $149,173.90 today, you'd have $3 million in the bank 43 years from now at 7%. So for somebody that's maybe a college student, this would be their kind of magic number. If they have this much in the bank today, they probably don't need to save any more for retirement, maybe. Now they might need more than $3 million. But anyway, for this part, it says how much would you have to invest every month. So we need to calculate the payment here. And again, $3 million, same formula here, or same variables here, different formula. This is to calculate how much we got to put in every month to get to the $3 million. So this is how much do I need just sitting there, and this is how much I got to put in every month, which is $915 per month to get to the $3 million. And that's about it. So hope this video has helped you get ready for the final or to get ready for the test in the current semester.